Let's integrate x plus 4 over the square root x minus 5 dx using U-substitution. To do that, I'm going to let u be the expression x minus 5, this part. So the differential of u is going to be the differential of x minus 5, which is dx. We can move on to substituting. So I'll have the square root of u, since u is my x minus 5. Dx, I can substitute with du, and I see that what I'm left with is this x plus 4. I don't have an expression for x plus 4. However, because u is equal to x minus 5, x would be equal to u plus 5. So my numerator, I can substitute u plus 5 for that x, and I'll still have to add 4 after that. So let's clean this up a little bit. U plus 5 plus 4, that would be u plus 9. And if I'm going to divide by the square root of u, that's the same as multiplying by u to the negative 1/2 power. Now, before we actually take the integral, I'm going to simplify this expression a little bit further by distributing the u to the negative 1/2 inside of u plus 9. Doing that, u times u to the negative 1/2 is u to the positive 1/2 plus 9 u to the negative 1/2 du. And I'm ready to integrate. So, with powers, I'm going to take the power and increase it by 1. So adding 1 to 1/2 leaves me with 3/2. And divide by that 3/2, leaving 2/3 as a coefficient. For this 9 u to the negative 1/2, I'll add 1 to that, making it positive 1/2, and then divide the coefficient by that 1/2. And don't forget about your plus c at the end. Last step is to clean up any coefficients as well as substitute that x minus 5 back in for the u's. When I do that, I'm left with 2/3 times u, which is x minus 5 to the 3/2, plus 9 divided by 1/2 is 18, u, which is x minus 5, to the positive 1/2, plus my constant of integration. And there is our indefinite integral.